Okay, good day, good morning. I'll have a different format for this video, which is going to be without me in it. And I want to I'm going to target the lesson more. And so this will be a shorter video, probably, and more to the point. I was fumbling around there a little too much. So if it's all the same to you, I'll record on the screen on this contraption I've got here, this recorder. All right, so far so good. I hope it seems like we're all doing well here. And so far, not everybody, but I'm with you. I want you to know I'm here, available through the Remind application, the app. Contact me through that during the class times. And the class times will go from either, ideally, between 1 and 3 and 3 to 5. Those are my work times. That's when my classes are in session. I have 2 different classes, so I lumped you all together in the XYZ homework. That's why you'll notice you have that 4-hour window instead of the 2-hour window. And it's my job to keep you there in class time. Otherwise you could do it any time, but I'm under orders that we have to meet during class times. And this is how I'm doing it. I'm recording this lesson for you to watch outside of class time, but then when you come to class time, you actually do the homework. And it's not going to take you that long to do it. Not with the, some of the times it took for you to do the test, some of you, was extraordinary. I don't know how you get 30 problems done in 10 minutes. Okay. But I can't worry about things like that. I will tell you, we will have, if we're back in school in time, which they're wanting us to do for the final exam, you will need to know all this. So don't, you can scam on it right now in between, but when it comes to the final test, which is worth 20%, you're going to want to know how to do these problems. So kind of hang in there and do them. Okay, so back to what I'm talking about here is we're on 6.2. And again, this is going to be the video you're going to watch for Tuesday's work. Next Tuesday, I don't know the date, I don't have a calendar with me, but follow that. Is it the 31st? Tuesday, what passed was the 24th, and add 7 onto that, and I think it comes to be the 31st. Okay, nevertheless, let's get rolling here. So we're going to be simplifying radicals. And radicals are this square root sign, perhaps, that we're familiar with calling it square root sign. All right, but the index number can be anything. Usually it goes up to 2. 2 is the square root, and 3, 4, 5, etc. And that index number is represented by the n. And this can be x or any kind of a number there. All right, we went through that in that little crazy video I made. It was a little bit rough, but I hope you managed to struggle through that. I showed you what that all meant. All right, so we have a couple properties in 6.2 that we want to talk about. And that's the product property for radicals, where the nth root of a times b equals the nth root of a times the nth root of b. Okay, so this one comes up sometimes. We're not too concerned about this one. It's the quotient property that's really helpful, because then we see problems written in this form. And what about it? Well, we can split that up. So these are equivalent expressions. So this is the nth root of a divided by b, which equals the nth root of a divided by the nth root of b. And again, we can split that up, and we'll learn how to rationalize the denominator in a little while. All right, so let's go through some examples. One other thing I wanted to mention, if you haven't read the book, is we are dealing with, if I'm dealing with the square root of, say, 4, well, realistically, I have 2 answers for this, where I could say this equals negative 2 or positive 2. because -2 squared and 2 squared, they both end up equaling 4. So what we're going to be dealing with is what's called the positive square roots. So we don't worry about saying -2 and +2 as our solutions for something like this. We're just going to say that our answer is the positive square root. We always like our numbers to be positive, so we're going to answer it that way. And then later on in this section here, we're going to learn that we're not going to know whether our answer is -2 or +2. And then in that case, then we're going to write the absolute value of that number. But I'll show you that when we get to it. Okay, so let's start with writing the square root of 50. Here's example 1. And I've got the square root of 50. All right, so ideally, what I want to do is I want to take the 50 out, and I want to do the prime factorization. So I can say this would be 2 times 25. You could go 5 times 10 if you wanted, but 2 is a prime number, and then the 25 I'm going to break down to be 5 times 5. Okay, and notice I'm circling them too because I don't want to lose sight of what I'm doing here. All right, so now I can take these factors, put it inside the radical, 2 times 5 times 5, and now I want to go and do my rule that I was talking about to say for every 2 of the same number, because this is a square root, there's really a 2 here. For every 2 of the same number, I want to take one of them out. All right, so here I've got 2 5s. 5 times 5 is 25. I could say the square root of 25 is 5, but in the way I'm doing it with you is to say I have 2 5s. I want to take one of them out. If I take one of them out, what's left under the radical sign? That 2. So my answer would be 5 root 2, because I can't do anything with the 2. I'm trying to look for a square root of 2. Well, I get a decimal number, but we don't take decimal numbers here. This is what's called the exact answer. And it'll help you when you're answering problems. Okay, so that was our first example there. Okay, here is, let me label these so you can reference them back if you like. This is example 2. Here I've got the square root of 48x to the 4th, y to the 3rd. All right, so I could explode this thing if I wanted. You know, I could take the 48, first of all, and then do my simplification, or factorization, I should say. So 6 times 8 is 48. 6 breaks down to be 2 times 3. And the 8 will break down to be 2 times 4. And then the 4 will break down to be 2 times 2. So here is R is my prime factorization. So I've got the square root of 2 times 2 times 2 times 2, and then times 3, just for the number. This number here. So for every 2 of the same number, I'm going to take one out. So here's 2 2s, one comes out. Here's 2 more 2s, so that's going to come out. I'm just going to multiply them together. And what's left under the radical then is the 3. So far I've got 4 root 3. That's the numerical value. Okay, then I've got x to the 4th. Well, there's 4 x's, and for every 2, I'm going to take one out. So I could go 1, 2, 3, 4 x's, and then 3 y's, and do them all at once. And for the variables now, I'm looking for the square root of this, x to the 4th, y to the 3rd. And again, for every 2 x's, I'm going to take one out. Take one out. Here's 2 x's here, take another one out. Now I'm just going to use the degree of the term. And here I got 2 y's, so 1 y comes out, and 1y looks like it's staying inside. So what have I got here? Well, here's my numerical value of 4 root 3, and then I'm going to take out the x squared y from the radical here for the variables. So this is going to end up being 4x squared y, and then it left under the radical is going to be the 3 along with this y. We had 3 y's to begin with, and now I'm just going to have 1 left over because I can't do anything with the square root of 3 or the square root of y. So this would be my final answer for that problem. Okay, how about example 3? I think I got 10 or 11 of these examples, so bear with me. Okay, so here I've got, I could take this whole thing and explode it if I wanted to. So what do I mean by that? I mean this. I'm going to take the 40 and break that down. So I got 10 times 4. 10 I can break down to be 5 times 2. And the 4 I can break down to be 2 times 2. And now what we're saying here is, what is the cube root of this number? Well, that means for every 3 of the same number, I'm going to take 1 out. Okay, so here I've got 1, 2, 2, 2, 3 2's here. I'm going to take 1 of them out. So so far, this problem, I'm going to have 2 of the cube root of 5. That's what's left over. Okay? Kind of look at that, replay it, I guess is what I can say now, but I'm probably going to repeat myself constantly. So I had 3 2's. This is the cube root. So for every 3 of the same number, take 1 out. And I did that here, and I got 5 left over under the radical. And now we've got the variables to contend with. Remember, I could say that I could divide that into this 3 index into the 5. It goes 1 time with 2 left over. But until you get the hang of that, I'm going to say I'm going to take A times A times A times A times A. That's the prime factorization of A to the 5th times B to the B times B times B times B. And I'm going to look at it this way. The cube root of A to the 5th and B to the 4th. And the same thing persists. For every 3 of the same letter, I'm going to take 1 out. Here's 3 A's, so 1 A comes out front. I only have 2 left over now under the radical sign, so I'm left with that. I have 3 B's here. I'm going to take 1 out front. Okay, and it looks like I have 1 B left over here. So now for this part, I'm going to have the cube root of A squared and B for the variable portion of this problem. I'm going to put the 2 together now. So my answer is going to be 2, this 2, and the AB, and multiplied to the cube root of A squared B. And that looks like my answer for that particular problem. Okay, wait a minute, I'm forgetting the 5. Oh, there's the 5. I thought that was a little strange looking. All right, so let me change that a little bit. Got to get it right. And I got 5 A squared B. That's much better. All right, example 3. Okay, how about the square root of all this? All right, now let's see. So I got a 12 here. And when I do that prime factorization, it's 4 times 3. But then I know that 4 is going to be 2 times 2 times 3. So here's my factorization, prime factorization, I should say. And it looks like I'm going to have, let's see, I have 2 2, so 1 comes out front, and I'm left with the square root of 3. All right, so that's for the numerical value. And then I've got x to the 7th and y to the 6th. So here, I'll show you that other way. I did it in the first video. So there's really a 2 here. So now for my variables, I could say 2 goes into 7 3 times with 1 left over. Okay, so let's see. I would have 2 goes into 7 3 times. So that means I'm going to have x to the 3rd. And then under the radical, I'm going to have that leftover x, which would go here. And then I've got 2 goes into this 6. Remember, that's an exponent 3 times. So that means the y is going to come out here and be y to the 3rd. So far, so good. Now we got to determine what's left inside. Well, here's my numerical value, 2 root 3. So that means that I'll use it over here. So I'm going to put the 2 out front here, and the 3 now is going to go inside with the x. So again, let me just move that over a little bit, and this will be 3x. And that would be my final answer for this problem here. A little bit different working with the variables on this one. And again, if you like doing it the other way, but I just didn't want to write 7 of these x's. This is it here. Now this is saying what's the square root of that? And here I've got, I'll continue on. Y, 6 y's. 4, 5, 6. 6 of them. Okay, and again, repeating myself. For every 2 of the same color, not every 2 of the same variable, I'm going to take 1 out. So here I got an x, 2 of them. Here's my first x. Here's 2 more. So I'll square this one. 2 more, make it a cube, and I got 1 left over. Now move on to the y. Here's 2 y's. 1 comes out. 2 more. 1 comes out to square it. And 2 more, and this will cube it. And there's my how it can handle just the variables now again. The other way of doing it. Okay, it's a fun way of doing it, and then you really sharpen up your math skills with your basic, facts, math facts. Okay, next problem. Okay, this is example 4, part B. And now I'm dealing with the simplifying the cube root of 54, a to the 6th, b to the 2nd, and c to the 4th. Okay, so let's do the 54. And 2 numbers that equal 54 that I know of is 9 times 6. The 9 can break down to be 3 times 3. And the 6 will break down to be 3 times 2. And then I can take the cube root of these factors. And the index number is 3, so every 3 of the same number, I'm going to take 1 out. Let's see, can I do that? There's 1 3, 2 3, 3 3s. So I'm going to take 1 of them out. That's going to go here. And what's left is the 2. So I got 3 root 2. For the numerical value of 54 this time. Oh, what's important is to put that index number there as a reminder that it's a cube root for the reader who's reading this, which would be me. All right, now I've got the variables to take over with. All right, so this time I'm going to do it like this. I'm just going to get cute here with a times a times a, 6 of them. 1, 2, 3, 4, 5, 6. Then I've got 2 b's, bb, and 4 c's. And I'm going to look at it this way and say, what's the cube root of all this? Scooch up here a little bit. All right, try it. So I've got 3 a's here. 1 comes out. 3 a's here again. One more comes out, so it's a squared. Notice here, it's a cube root of b times b, but there's only two of them. So that's got to be left in the radical, under the radical sign. So that would be like b squared. And then the c's I'm going to take care of the same way. I got three c's here, and one of them comes out here, and one of them's left over. So here are my numbers, my facts, and I got to put them all together. So on the outside then, I've got the 3a squared c. So I could write that as 3a squared c times the cube root of, what have I got here? This 2 will go first. Numerical coefficients go first. 2b squared c. And putting it together, I'm all done. We're all done with that problem. Okay, works nicely doing them separately. I like it that way. I'm organized. Putting it together like I just did is efficient, and it works. All right, let's try example. We're talking about next is rationalizing the denominator. And I'll just show you in the context of the examples now for rationalizing the denominator. What does it mean? All right, in our second objective here, B, you'll notice if you're following along in the book, and they talk about rationalizing the denominator. Now I could have, remember that, how would we have that? I had the square root of a over b that equaled the square root of a divided by the square root of b. And there is a rule saying that we can never leave the denominator with a radical in it. All right, so we had there's a way of eliminating it by this, which I'm going to show you in this next section. All right, but that's the idea of rationalizing the denominator. Why do we do that? Because I got to get rid of the radical in the denominator when we have one. All right, so let's do a little example here, and that would be, how about the square root of 3 over 4? Well, if I write this up, if I separate these two, I've got the square root of 3 over the square root of 4. Well, 4 just happens to be a perfect square number, so that's just going to come undone by itself without doing anything. So my final answer here would be the square root of 3 over, what is the square root of 4? Well, it just happens to be 2. So this is my solution here. Okay, next example. All right, so I want to simplify the square root of 5 over 6. Okay, so now on this problem, I'm going to take this and separate it. So I got the square root of 5 divided by the square root of 6. And now I can see that these are not perfect square numbers, so that idea isn't going to work. So what this is basically simplified, but I have to get rid of that that radical in the denominator. So I have to rationalize the denominator. All right, so what that means is I'm going to multiply the top and bottom here by whatever the denominator is. So this is going to be the square root of 6. And top and bottom square root of 6. So that means I could write this up as the square root of 5 times the square root of 6 is the square root of 30. And then the square root of 6 times the square root of 6 is the square root of 36. We're allowed to multiply the radicals, the numbers under the radical signs, and get the result here. Now, by doing the denominator, I'm multiplying it by itself. It's just going to end up being, well, you can just figure it out. What's the square root of 36? And it's a perfect square root now by multiplying these two by each other. All right, so what I'm going to end up here with is the square root of 30 over 6. And that's my simplified form here. And notice the radical is not in the denominator. I can't simplify the 30 more. It's not, we're not able to. We couldn't do it here, so we're not going to be able to do it there. Okay, try another one. Let's see, where am I here? Example 6. Well, I have it here. Here's example 7. And how about the 4 over the square root of 3? And what they're saying to do is rationalize the denominator. So if I'm rationalizing the denominator, I'm going to multiply top and bottom by the square root of 3, because that's what the denominator is. When I do, I end up, the top now is going to be 4 times root 3, and that's going to be over, well, let's see, this is going to be the square root of 3 times 3, which is 9. So then the square root of 9 is 3. So this is going to look like 4 root 3 over 3. And voila. That's what I've got here. No further simplifying can be done. So I'm done with example 7. Was that example 7A? This is A, then I've got a B here. Let's try and squeeze in B. And B is going to be 2. Oh, a little different here. I've got 3x. And that's going to be divided by the square root of 5y. All right, and again, my orders here are to rationalize the denominator. So I'm going to multiply this top and bottom by square root of 5y, top and bottom. You'll get the hang of what that denominator is going to be ahead of time from doing this. So I'm just going to do it the old-fashioned way. Not in a hurry. I'm taking my time. I'm concentrating on learning this, and I'm into it. So let's see. We've got these two guys here are going to multiply together. Now I can multiply what's under the radical sign. All right, the 2 is just going to come along with that. So this is going to be this 2 and this 2 are the same. And then I'm going to have the square root of, let's see, 15. 3 times 5 is 15, and x times y is xy. Fair enough? Fair enough. And then I've got 5y times 5y is 25. This is the last time I'll do it this way. Then I think you'll get the hang of what the answer is going to be. When I multiply these two together, my answer is going to be 5y, just one of the two. So this is going to be 25y squared, but it's still under the radical sign. So what I'm saying is, what is the square root of 25y squared? Okay, I know what it is. It's one of these two. So my final answer here is going to be 2 square root 15xy over, what's the square root of 25? 5. What's the square root of y squared? Y. And now this is my final answer. We don't cancel these two y's at all, because this y is under the radical sign. This one is not. Okay, so there you have it. Okay, so now we've got example 8 is we're going to rationalize the denominator that has cube roots. Cube roots in it. Okay, we're going to rationalize those. So that works similarly. And it's going to look like this. Here's my example 8. So I've got 7 over the cube root of 4. These are kind of cool. Oh, let me squeeze in here. All right, so I could say, kind of look at this a couple different ways here. Actually, I think I'll do it two separate ways, I think. Let's see, if I'm rationalizing the denominator, so that means I'm going to rewrite this to be, I'm going to multiply top and bottom here. Let me cheat a little bit here and get so this is going to be multiplied to, now this is a cube root, so I got to create a cube root here. So let's see, I have 1 4 here now. What if I multiplied top and bottom by, say, 4 to the second power, which is 16. Let's see if I'm going to do this right. So I got 16, and not the square root, it's the cube root, and then top and bottom. So I got the cube root of 16. All right, so now what this is going to do by multiplying it by 4 to the second power, actually I got a better idea. Let's see, let me get rid of this 16, and I'm going to write this up as, if this is 4, and then I need a cube root, meaning 3 4s, then I'm going to write this up as 4 to the second power. All right, and then this one I can leave as 16, because that's what it equals. All right, so when I go about doing this, let's see, what's my top number going to be? 7 times 16, that's going to be the cube root of, can I break down the 16 at all? Let's see, can I do anything with that? Well, let's see. I'm going to bring the 16 over here, and then I've got 4 times 4, and then that's going to give me 2 times 2 times 2 times 2. There's my 4 2's, but it's the cube root of this. I'll put it under the radical, the cube root, and that means for every 3 of the same number, I'm going to take 1 out. So here's 3 2's. I'm going to take 1 of the 2's out. I got to come over here, and then what's left? So this is going to be the cube root of 2. This 2 is on the inside, and 1 more 2 is going to be on the outside. Kind of clear that up a little bit, get me some room. So that is going to be on the outside. And that's what this numerator is. Then I've got to multiply this by 7. 7 times 2 cube root of 2. Well, when you do that, you're just going to multiply 7 times 2. So you're going to have 14 on the outside. I'm prefabbing this, and then I got to end up moving it over, but that's okay. So it's going to be 14, and then here I've got the cube root of what's left over, which is 2. So that's what my numerator ends up being. And then how about, let's see, what can I say here? 14, then the denominator. This is going to end up equaling, well, I've got 1 4 here and 2 4's here, so this is going to end up being the cube root of 4 to the third power. Because 4 to the first power times 4 to the second power is 4 to the third power. And now I can see I've got 3. 3 goes into 3 once if I want to do it that way. But invariably, this is going to end up equaling 4, whatever number is here. So I've got 14 cube root of 2 over 4. Then it looks like I can do one more thing, and that's simplify the 14 over 4. So this I'll bring down here. It's going to give me 7 cube root of 2 over 2. And this is my final answer for doing it this way. Remember, I took the number that was already given me and then squared it So when I multiply it, I get 4 to the third power. And that's a perfect cube number. For every 3 of the same number, I'm taking 1 out. So I have 3 4s here, so one of the 4s comes out, and that's why I ended up with this 4 here. Now, another way of looking at this, if you're sharp, is you could say, let me rewrite this problem again, which is going to be 7 over the cube root of 4. But I can also see that this is written, I could write this up as, which is equal, 7 over the cube root of 2 times 2 to the second power. Okay, if I'm going to rationalize the denominator, now I can just multiply this top and bottom by what? The cube root of 2 to the first power. And same with the top here, cube root of 2. When I do that, I end up with the denominator, now you can see, is going to be, I'm going to have 3 of them, because this is 2 to the second power times 2 to the first power is 2 to the third power, and I've got the cube root of 2 to the third power, which is 2 times 2 times 2. For every 3 you take out 1. So what do I end up with? This here is going to be, I'll write my answer over here, 2. The cube root of 2 to the third is 2. Then up top here, I'm just going to multiply these 2 together, and that's just simply 7 cube root of 2. And that would go over here, 7 cube root of 2. And I get the same answer. This way is much shorter than doing it the other way. I was dealing with larger numbers here. So you can check that out, watch it a second time. The trick here is to recognizing the 4 as 2 to the second power, where I have 2 2's. This one, the first way I did it, I took the 4 and just added 2 4's to it over here. Let me change my color here if that's helpful. I don't like that color, but that's all right. So here, this is what I'm talking about. I had 3 cube root of 4 multiplied to 4 to the second power, the cube root of 4 to the second power. That gives you 4 to the third power, which is what I'm looking for, to take one of them out. All right. All right, here's example 9. We're getting there. How about it? Example 9. So here I've got the square root of this ratio. So let's split that up. So here I'm going to have the square root of 12x to the 5, y to the 3. Extend my bar there. And that's going to be over the square root of 5z. And it looks like I can do what here? I guess I can simplify this first. Shall I simplify this first? Or let's try it. I can take care of the top. I can do it 2 different ways. Let's see, I've got it here thus far. I suppose I can take this and simplify it. So that would be taking the 12. Take the 12 out here, and I've got 4 times 3. And then the 4 I can break down to be 2 times 2. And this 3 will come down here. So the square root of 12 would be 2 root 3. So here I've got 2 on the outside, and then root 3. Then let's take care of the x's. So here I got x to the 5th. Remember, there's a 2 here. So 2 goes into 5 2 times. So that'll give me, x squared with 1 left over on the inside. Remember, I can take the 5 x's, 3, 4, 5, and say, what's the square root of that? For every 2 of the same number, take out 1. And there you have it. Same thing as we have up here. So this ends up being x squared root x. And that's what I've got here so far. Same with the y to the third. 2 goes into 3 one time. So that gives me a y on the outside. And what's left over is 2 goes into 3 one time. And then I'm going to have 1 left over. So this y would go here. And if I am doing y times y times y, you can see I have the same thing going on. Square root of y times y times y. For every 2 of the same number, take out 1. And as you can see, I've got y root y. All right, so that's the simplification of the numerator. I've got to deal with rationalizing the denominator. So this is this. These two are equal. And then I'm going to put the square root of 5z back here. Okay, so let me erase this so I can continue on. All that here. Okay, and this is where I'm at thus far. So now I'm going to multiply top and bottom by the square root of 5z. And the square root of 5z, top and the bottom. All right, so what have I got? This is going to equal, I got to take care of my top here. So under the radical signs, I can multiply those together. So this 2x squared, y stays intact. And then I'm going to have the square root of 15 xyz. Okay. And now the denominator is going to be these two, which is the square root of 5z times the square root of 5z is 5z. And looks like that's my answer. A little bit of a toughie, but not really. Knowing the rules helps. All right, that was example 9. Okay, here is a couple problems when we're talking about using the absolute value. This is a little confusing because we kind of just lend towards going to the positive square root of a number. So in this case here, they're giving us a little curveball because we know that at the beginning of this lesson, I was talking to you about the square root of 4. And whereas the square root of 4 could be negative 2 or positive 2. All right, and some problems allow for that your answer would be negative 2 or positive 2. All right, but we have to specify that by saying if it ends up being a negative 2, we have to put absolute value bars around it so we get the same answer. So instead of just saying use the positive square root, no, they go through this kind of like legal jargon for us to ascertain. All right, so if we know a is positive, then the square root of a squared is a. All right, so that's basic and pretty simple, the positive square root. All right. All right, part 2 of this, if we know a is negative, then the square root of a squared equals the absolute value of a, which again would give us a, positive a. Okay, all written in what they're asking in the problem. And we'll see if we can point that out as we go. And then here's our last property rule. If we don't know if a is positive or negative, then the square root of a squared is the absolute value of a. That way we cover it if our answer is negative. Or positive because we don't know. So again, mere technicalities here with the use of this. But we want to be careful when we're doing our homework that we get it right. Okay, so let's see if we can figure this out. going forward. All right, I'm pointing this out, writing out the specific directions in example 10, where it says simplify each expression. Do not assume the variables represent positive numbers. So what they're saying is it could possibly be negative. All right, however, we want our answers to be positive. We want to show that they are positive square roots, which is a case in where we're headed. All right, so what you have to do here is to say, let's see, we got 4 of them. So A is, let me scooch that up. I've got the square root of 9x squared, which is the square root of 9 is 3, and the square root of x squared is x, but it says do not assume the variables represent positive numbers. So we can't assume that. And they're talking about the variables, so I have to put the x with the absolute value sign to make it positive. Okay, instead of saying take the positive square root, which we have been doing throughout this lesson, that's fine, but now they're throwing this in to saying it's possible it could be negative, but they want us to make it positive. So I'm a little confused myself on that one. But this is the answer they're looking for. 3, absolute value of x. Here's B. See if I can do this. This is the square root of x cubed. Okay, so what does that mean? Well, there's 3 x's there, so I'm going to take one of them out. For every 2, take 1 out, and then I'm left with the square root of x. And now I took that x out, but what does it say? Do not assume the variables represent positive numbers. Do not assume that they are representing positive numbers. So I've got to put this x on the outside of the radical in absolute value bars. Notice it's the one that comes out. Whatever comes out. This, well, that was a perfect square. How about C? Let's try C. So I've got the square root of this x squared minus 6x plus 9. And what about it? This ends up equaling, this is kind of cool. It's the square root of this. If I factor this, it becomes x minus 3 times x minus 3. And what about it? The square root of x minus 3 times x minus 3. Oh, these are 2 factors that are the same. For every 2 of the same number, you take 1 out. So here's 2 of them, and I'm going to take 1 outside the radical, which is x minus 3, and there's nothing left under the radical, so that goes away. And so you've got to, what is it saying? Do not assume the variables represent positive numbers. So in this case, this x minus 3 is going to be in absolute value bars because it represents one number. Okay, and finally D, I believe that is to be true. D, I've got the square root of x cubed minus 5x squared. And what do I do with that now? And it looks like I got to factor this. I want factors under the radical, not add-ins. All right, so this one I can take out an x squared, and what's left is x minus 5. Okay, so let's take the square root of that. So let's see, the square root of x squared is x, so that's going to come out front. And what's left under the radical is the x minus 5. And then what is it we have to do? Because of the instructions, do not assume the variables represent positive numbers. Can't assume that, so we'll make sure it's positive by putting absolute value bars there with that problem. Okay. Well, this is the last example, example 11. All right, so here we talked about this before in the first video in 6.1, but now I'll elaborate on it a little bit more. to say that, remember we were talking, and if I had a negative 9 here, I could say, what is the square root of negative 9? And then we say it does not exist for the square root of negative 9. All right, so you recall that. I hope you recall it. All right, but now we're getting into odd index numbers and then a negative. So I could look at this as saying, what's the cube root of negative 2 to the third power is negative 8. All right, and because I have an odd number as an index number along with a negative number under the radical sign, this is possible now because of this. That's what it is. Negative 2 times negative 2 times negative 2 is negative 8. So then we can come up with an answer for this. So this one is just simply going to be negative 2 because there's 3 negative 2's. So for every 3, you take 1 out, and this is the one you're taking out. Okay. And again, break it down if you want. I kind of like doing that. The cube root of negative 2 times negative 2 times negative 2, which is to the third power. And the index number tells you for every 3 of the same number, you take 1 out. Well, here's negative 2, negative 2, negative 2. Negative 2 comes out front. Nothing left under the radical. And that's your answer. Okay, so same with the part B in this example, where I've got the cube root, and they're presenting as negative 5, in parentheses, of course, raised to the third power. So this is, 3 goes into 3 one time, so you end up with negative 5. There's 3 negative 5, so for every 3 you take 1 out, there's the one you're taking out. Okay, so that is possible. And okay, and let's see if A is a real number. I could write you that, and I don't know if that's going to matter. I'm going to let that go, that last part. Bottom of page 528. All right, so that's it for section 6.2. And I hope you like this video better than the first one. I feel like I did a little bit better of a job here going through the examples and getting the information that you need to know quicker. And I'll let it go for now. Remember, you can always contact me through Remind or a direct email for when you have questions over the homework or just questions in general. Okay, so until next time, we will talk to you later. Goodbye.